And the next example is negative 1 to the power n plus 1 n squared divided by n cube plus 1, right? Now here you can see that it is an alternating series and bn is equal to this one. Now to check whether these conditions are satisfied, it is obviously true that all the terms are positive. I mean all the terms in the sense bn terms, where our bn is equal to this one. Okay, now be careful, we are not taking this one when you take the bn term, but in the previous case, in order to consider this limit, we took all like the complete term inside the sigma notation, right? Okay, so in order to check this first statement, we need to see this decreasing property, and checking the decreasing property is a bit difficult if you follow the usual pattern. See, you need to have the n plus 1. Now to get this one you will need this inequality, and for this one you can just cross multiply it, and then you should solve to a simpler version and then go in the reverse direction. But instead of doing it like this, in order to prove the decreasing property, we can get a different approach, and that will be by considering the function, the real valued function from the set of real numbers, and the function that we are going to consider is this one, right? That's the exact same term as the bn, but instead of those n values, we consider a function on a real number set, right? But if it is n, that is just for the integers only. Okay, so now our bn was equal to n squared over n cube plus 3. See, here we have x squared over x cube plus 3, which is a function on the set of real numbers, right? And then what we are going to do is we consider the first we take only the positive real numbers, okay, because there is no point of dealing with negative numbers since this n takes positive numbers, right? So our domain of the function is defined to be the set of positive non-negative real numbers including 0, right? And then we differentiate this function, right? So if you do the differentiation correctly, you can see that the derivative of the function is equal to this one, right? Then you can see that the derivative less than 0 means this less than 0, right? 2 minus x cube over x cube plus 1 less than 0, right? Here it is x cube, and that means not 1, 0, right? F prime is equal to this one, so f prime less than 0 means this thing less than 0. So by cross multiplying the denominator, it implies that x times 2 minus x cube less than 0, right? So now now we know that x is a non-negative number, right? And if x is equal to 0, then this product will anyway be equal to 0. So from this inequality itself, it says that x is not equal to 0, and also from the choice of the domain, we know that x is not a negative number. So definitely x is a positive number, right? So we can just cancel x out from this inequality, and we end up with this one, right? And that means 2 less than the cube root of 2. Not that. X greater than the cube root of 2, right? So from this one going backwards, we can say that if x is greater than this number, then the derivative is negative. So our function, for our function fx, if the x value is greater than this number, which is a positive number, cube root of 2, then after this point the derivative of the function is negative. In other words, the function should decrease, right? So it will be a decreasing function. That means for all these integer values also, that decreasing property will hold true. So a number n, and for a number n plus 1, since the function decreases, we will have this relationship, right? So in other words, since the representation of fx and the representation of bn tally each other for all the numbers greater than this value, which is like for this one it is somewhere close to 2, but it's a number greater than 1 and less than 2, right? Because if it is 2, then the cube will be greater than 2, right? So that means except for n equals 1, for all the other n integers, this relationship will hold true, right? Not this way, the other way, right? This decreasing relationship will hold true for all the n values greater than 1 but not equal to 1. Okay, so we should understand that for any value, but like it is not true for any n. Okay, it is only true when n is greater than 1, right? But here in this statement they have mentioned for this condition to be true for all n. So our only concern is what will happen when n is equal to 1. So we can even do that manually, right? When n is equal to 1, that means b1 is equal to 1 squared 1 cube plus 1, that is equal to 1 over 2, and b2 is equal to 2 squared 2 cube plus 1, and that is equal to 9. And you can see that this is equal to 0.5 and this is equal to 0.4 something, right? So we have b1 greater than b2, and from 2 onwards we already have the relationship of this decreasing nature that is derived from this calculation. So putting all these things together, we have this decreasing relationship for all the n values, right? And finally for this one, we can easily figure out that the limit of bn when n goes to infinity, that means the limit of n squared over n cube plus 1 is equal to 0, right? So both these conditions are satisfied and it is an alternating series with bn greater than 0. So from the alternating series test we can say that this series converges. And we will do one more application in the next video.